A pleasant day to all. Today, the discussion is about application of definite integral using word. This presentation contains the application of integral calculus in civil engineering. Integral calculus is used to help determine a function's antiderivative and is widely applied to strengthen designs and improve infrastructure. However, this particular discussion mainly focuses on the application of definite integral using work. So what is work? In calculus, it is simply the product of the force acting upon the object over a given distance or displacement. So here are the important things to know when we use work in the application of definite integral. So the first step is to sketch and graph the plate, then input it all into the given formula and integrate the function to solve the work. And calculating and determining the amount of work, a formula should be utilized. Work formula provides a precise solution to the given problem in the discussion. Hence, the application of definite integrals using work in civil engineering is relevant. So here's our methodology. First, we need to sketch and graph the plate. Second, find formula for the physical application of definite integral. Third, determine the values needed in the formula. And fourth, find the limits of interval of integration and integrate the function to solve the work. As stated, the plate requires work to be done to pump out the water from the given plate. So we use a formula of work in pumping out water. This formula is work is equal to weight and then the integral of height and the derivative of volume, where W is weight of water or liquid and h is the distance between the surface of water and the plate, and V is the volume of the plate. So here's now our results and the discussion. So here's our problem. A canonical plate is 8 meters high, has a radius of 4 meters, and is filled with liquid that weighs 45 kilogramic cubic meter. How much work is done in discharging all the liquid at a point 2 meters above the top of the plate? So as you can see, here's our graph and the sketched graph. So we have here our canonical plate that weighs 45 kilogram cubic meter and the height is 8 meters. And from the surface, we have the height of 2 meters and its radius is 4. So times 2, the diameter of this is 8 meters. So all in all, we have 10 meters. So here's our formula to be used in our problem. So we have work is equal to the weight and then the integral of height times the derivative of volume. So here's our given. Our weight is 45 kilogram cubic meter and our height is 10 minus y. And the derivative of v is equal to the pi r squared dy and or it equals equal to pi x squared dy. So how to get the derivative of volume? So here it goes. So we have x over y. So our x is our radius. So we have 4 here. And we have y, which is 8 for the height of the plate. And then, so as we simplify, so we get 1/2, or to get x, so we have x is equals to y over 2. So our dv is equal to pi y over 2 raised to 2 dy. So let's us now integrate our work. So integration work, pumping out water. So our limits is from 0 to 8. So from the origin or from the base up to the top of the plate. So we have our formula. So let's evaluate. So 45, and then the integral of our height is 10 minus y, and then pi x squared dy. So let's put our limits. So we have 45, the integral of 10 minus y pi y over 2 squared dy from the limits of 0 to 8. So as we evaluate, so we have 45, so 10 minus y, and then pi, and then y over 2, so we have 3, so 2 plus 1 is 3, and we will have over 3, so the limit of 0 to 8. So we have 45 times 10 minus 8, so our y is 8, right? So let's put the limits. So we have pi, then 8 over 2 cube over 3, and then the 0. So we have 10 minus 0 pi 0 over 2 cube, and then over 3. So we will get 45 times 512 over 3 pi. So as we multiply these two, so we will get 7,680 pi kilogram cubic meter. So here's our final answer. So let's go to the conclusion. So therefore, it was concluded that work is the result of force acting on an item over a specific distance. Furthermore, work formula is utilized to pump out the water from the given plate. This shows that there is a significant amount of work involved in emptying the entire plate. So that's the end of our discussion for today.